Hello everyone. In this video we're going to look at how to find the inverse of a matrix. We'll start off with the inverse of a 2 by 2 matrix, and then later on we'll build on up to the inverse of a 3 by 3, and once you're fully equipped you can look at the inverse of a 4 by 4, 5 by 5, and so on. But you don't need to do that because now there are tools to help you achieve all these operations without going through the hassle. So the inverse of a matrix requires that you find two entities. All right, so if I want to find the inverse of A, I need to know what is known as the determinant of the matrix and then the adjoint of a matrix, and from there I can find the inverse of a matrix. So the inverse of a matrix is such that if I have a matrix A, then if I multiply A by, say, matrix B, and I'm getting the identity matrix, then it means that matrix B is A inverse. Okay, so for example, if I have 5 and I multiply 5 by its inverse, 5 to the power minus 1, I'm going to get 5 to the power 1 plus minus 1, and that is going to give me 1. Alright, so 5 times its inverse is giving me 1. So if I have a matrix and I multiply by another matrix and it's giving me 1, which is the identity matrix, then that matrix, matrix B, is known as the inverse of matrix A. Alright, so A times A inverse is the same as A inverse times A, and this is equal to the identity matrix. Alright, now let's look at the matrix, a 2 by 2 matrix, to find the inverse of a 2 by 2 matrix. So for example, if I have matrix A given as A, B, C, D, then first I need to find the determinant, and then I find the adjoint. Alright, so to find the determinant of a matrix is simply the absolute value of that matrix. So A, B, C, D, and this is equal to, for a 2 by 2, is the product of members on the leading diagonal minus the product of members on the other diagonal. Okay, so I'm going to have AD minus BC, and that is the determinant of a 2 by 2 matrix. Product of members on the leading diagonal minus product of members on the other diagonal, AD minus BC. Now to find the adjoint of a 2 by 2 matrix is simply swapping the positions of members on the leading diagonal, negating members on the other diagonal. So for the other diagonal you do not swap them, you just negate them, but for the major diagonal or the leading diagonal you swap their positions. So instead of having AD, we're going to have DA, and instead of having B, we're going to have minus B. Instead of having C, we're going to have minus C. Okay, so that is the adjoint of a 2 by 2. So the inverse of a matrix is giving us 1 over the determinant times the adjoint of the matrix. And so if the determinant is equal to 0, if you put 0 here, you're going to have 1 over 0, which is undefined. Undefined times adjoint is undefined. So if the determinant is equal to 0, it means that the inverse does not exist. And if the inverse does not exist, the matrix A is said to be singular or non-invertible. But if the determinant is a non-zero number, okay, so you have 1 divided by a non-zero number, which is going to be not undefined. All right, so if the determinant is a non-zero number, it means that the inverse does exist, and if the inverse exists, then the matrix A is said to be non-singular, not plural, non-singular or invertible. Okay, so let's look at real example. For example, I have matrix A, which is equal to 1, 2, 3, 4, and I want to find the inverse of A. Okay, so the inverse of A, first I need to find the determinant of A, which is absolute value of A. This is equal to 1, 2, 3, 4. All right, so this is multiply the members on the leading diagonal. I have 1 times 4 minus members on the other diagonal. So I have 3 times 2 or 2 times 3. Any of them works. So I have 4 minus 6. This is equal to minus 2. Now this determinant is a non-zero number. Therefore, the inverse exists, and such a matrix, matrix A, is said to be invertible or non-singular. All right, so we find the adjoint. And the adjoint, like I said, for a 2 by 2 matrix, is simply swapping the positions on the leading diagonal. So instead of 1, 4, we have 4, 1, negating members on the other diagonal. So I have minus 2 and minus 3. Okay, so this is equal to, inverse is equal to 1 over the determinant times the adjoint of A. And what did I get for determinant? 1 over minus 2 times the adjoint, which is 4 minus 2 minus 3 and 1. Right now, there's a number multiplying a matrix, and this is known as scalar multiplication. And in scalar multiplication, we multiply the scalar by each and every component of our matrix. Okay, so I have 4 times minus 1 over 2, minus 2 times minus 1 over 2, minus 3 times minus 1 over 2, 1 times minus 1 over 2, and this is giving us minus 2. I have 1 here, I have 3 over 2, and I have minus 1 over 2. Okay, now let's see if we can do the same thing in Python. All right, so since we are using the same matrix, matrix A, we don't need to rewrite the entire thing. Okay, we just simply type print okay, so Goka, not Goka dot. Now the function that does gives you the inversion of a matrix is known as len_org. Now len_org simply means linear algebra. All right, so Goka dot len_org. Okay, so len_org is linear algebra dot inv, and inv is inverse, right? So inverse, what matrix? Matrix A. All right, so if you're looking for inverse of B, then we put B here. So the same thing that we've been doing for the transpose, for the add, for the scalar, the product of matrix, we do the same thing for the inverse of a matrix, but this time the function that does the inverse is len_org.inv. Okay, so len_org.inv of matrix A, and then if we run it, we get in minus 2, 1, 1.5, and minus 0.5, which is the same as what we had, which is minus 2, 1, 1.5 is 3 over 2, minus 0.5 is minus 1 over 2. Okay, so it's straightforward. Now, if you want to do the same thing in Excel, then we simply select the row and columns that our matrix, the resulting matrix is going to be in, and then every equation in matrix start with the equal to sign. Okay, now we're finding the inverse of a matrix. Okay, and the function that does the inversion of a matrix in Excel is known as M inverse. All right, so the first M represents matrix, and then the inverse. Okay, so in Excel it's called M inverse, but in Python it's len, which is linear algebra dot inv, and then you put the matrix that you want to find the inverse of. So this is equal to M inverse. You open the bracket, and then it picks only one array. Okay, so pick an array, our matrix A. After that, Control Shift Enter, we get in the same thing. Minus 2, 1, 1.5, which is a 3 over 2, and then minus 0.5, which is the same as minus 1 over 2. All right, so irrespective of what tool you're using, you should get the same results. Whether you're going by it the manual way, or you're using Python, or you're using Excel, the results must always be the same. Unless you're doing something wrong somewhere, then your result is going to vary.